Hey everybody, so today we are going to be going over the main steps or components of AI training. And believe me, there's a lot of different recipes out there for how to do AI training. But specifically, we're going to look at where data integrity, or knowing where the data comes from, and data quality plays a larger role. And some of you might be surprised, some of you may not. And this is something that, again, there's a lot of recipes out there on, do you do fine tuning here? What kind of fine tuning? Do you have a pre-trained model? Do you train your own model? There's all kinds of different recipes out there. So this is going to be a general take on that. And honestly, if you don't know the different components that go into AI training, because I know that's kind of like a blanket term people throw around. There's a lot involved. And at the end, we're going to go over what this looks like when using it in practice. So if this sounds interesting to you, let's stick around. Now, the first step is creating the word embeddings. So if you have a vector database, for instance, it is going through and basically creating a map of all the words and how they interrelate with each other. The AI needs to be able to learn from that. And it doesn't have to learn through a vector database. It can be trained on lots and lots of unstructured and structured content to get this mapping or this embedding of how things interrelate to each other. And that's how it's learning about language, it's learning intent, it's learning all of these different things. Now, it doesn't know how to label the intent, it's just picking up those patterns. But that's usually where things start out. Now, where is data integrity and data quality helpful here? Well, knowing where your data came from helps you understand the level of quality. This would be the difference between maybe using a data set or a collection of content that is assembled by someone for just general training purposes. You don't really know who they are, what their intent behind the training set was. You're just using what was created and what's out there. There's probably some things in there you're not going to be comfortable with, or that you don't really understand, or that you don't want in there at all. And there's also a lot of good stuff in there too. That's usually how these pre-created training sets work. Especially if it's synthetic, it's just synthetically creating what would normally be out there in the world for training. So knowing if it's synthetic, how many iterations of AI are involved, right? So when you are looking at a synthetic piece of content, it is created by AI. But if you're one hop out from human intervention in that, where humans created something and then the AI learned from that and created a synthetic piece of content, you're only one hop out. The degradation is not too bad, but just like a piece of clothing that you wear and wear over and over again, the thinner the training is, the less quality there is. So you really want to know, if it's synthetic data, how many steps away is it from whatever the synthetic data is being mimicking, essentially. So that's number one. That's on the quality side. But knowing where it came from also helps you understand the quality, some of the things you might want to check out. But there's things that are a little bit more benign, like how comprehensive is that training? What are some elements that are missing? But the things that could become not benign are, were there things purposely excluded, or were there certain people groups or certain languages or certain cultures or worldviews that were heavily influenced in that training set? All of those things add up to maybe not a great model. So those are the things that knowing where the data came from and what the quality looks like is really important from the get-go. Garbage in, garbage out. So make sure if you are using a pre-trained model, you know what went into that training. It's not always easy to understand. Open models, of course, are a little bit more transparent. I don't want to say a lot, because open doesn't mean they tell you everything. But they are more transparent than the black box ones. So definitely look into some of that, or you can look at some research. There's a lot of people that are kind of kicking the tires on all these models to understand potentially what kind of things it was trained on. If it was only trained on the open web, there's a lot of complications and weirdness with that. Was it using licensed information like news or scholarship or certain social media, that kind of thing? That is going to be a little bit different and again comes with its own can of worms. So understanding all of this is going to be really important. And it's always the first step in any kind of AI or machine learning. You have a training set of stuff that the AI or just the machine learning model is looking at to pick up those patterns of human intervention, human interaction, and what we would expect as humans. The next part is model predictions and inferencing. You can fight it out in the comments about whether AI can infer things or not. I have my own opinions. If you are interested in that video, let me know. But there are ways that you can use things that are for sure able to do inferencing, which is like a knowledge graph. But then if you're looking at a statistical model, it is statistically trying to understand the probability of things. And this is essentially what I hate to put the human vernacular analogies in, but the AI brain, I put this in air quotes because AI is a statistical model. It's not a brain. It doesn't learn like a brain. Even if you're using reinforcement learning, which again is a part of this that could show up in either of these steps, at least semi-supervised learning was one of the most popular ways that people would do like auto classification and image and entity recognition kind of stuff in the before times of AI. But you can still see that today where some models will have some pre-tagged or pre-ER, entity resolution, entity recognition. All of those things can also show up in the training set step, but then there's also the learning step, which is where the reinforcement comes in, where there's no human intervention from a perspective of the human is directing the AI. But what it is doing is reinforcement learning. Again, every single one of these could have a whole video on them, so just keep that in mind. But it is a reward system. So the humans have to decide what is going to get rewarded. So while yes, it is unsupervised, it is still very much indebted to the human expectation and the guidance that humans give for that reinforcement. So the AI is going in and trying to predict and learn things, and when it goes too far afield, it gets a knock, so to speak, and then if it goes in the right direction, it gets rewarded. And so it goes on and on and on like that until it learns the proper approach according to humans. So again, in that space, if you don't have people that are enforcing the way that you want the model to run, what you feel is a good response versus a bad response, what is maybe the best context, or all of these different things that you want your model to be able to do. If you're not expressing that very well, or if you don't have your own understanding of what is going to be good versus bad versus maybe not so bad, so something that's more neutral, that is something that you got to do research on. I mean, what is your use case that you're using this AI for? If you're training the AI yourself, you better have a lot of research on what you want the model to do. If you're using a pre-trained model, there isn't a ton that you can do in these first two steps because that's what a pre-trained model does, is it has the predictive piece and the training set piece already built in. That's what a pre-trained model does. But if you're trying to look on us with a small language model, you can start to implement some of these yourself. But both of these are heavily dependent on knowing where the data came from. So if you're getting guidance from someone on that reinforcement, what is good, what is bad, how does it get interpreted, that's important. If you don't know where that data or that guidance is coming from, was it evidence-based? Did it just pop into somebody's head that this is the way to do it? Did they just hear that this is what some of the big players in the field are doing, and so they just started to mimic it themselves? You want to make sure that everything you're doing is based on true evidence as to why you should be doing that way. So that's where knowing where it came from, make sure it's evidence-based, is important, but also the quality, right? So even if you have it as evidence-based, if you're basing that evidence on a very small data set or a very small group of users or whatever it is, systems, whatever it is that you're looking at to gather your evidence, is it statistically significant? In corporate, you can't always get something to be, you can't do something that is statistically significant. Stumbled over those words. But it's not impossible. And even if you can't do according to scientific significance, maybe you have to make sure that all of your stakeholders involved understand what the risks are if you're doing a certain sample set. So that's another thing to keep in mind there. Another layer is fine tuning. So this is really where that reinforcement can show up. You can have pre-tagged data sets. You can have named graphs, right? So you can make sure that your model is looking at just a certain domain or discipline so it gets the right context. This is where, when you're doing that reinforcement learning, it's agent-based. So the agent is trying to figure out where to go and get its stuff, that it's consulting for the answer that it's trying to generate. That's, again, where some of that reinforcement, whether it's going to the right place or the wrong place, will kick in. Some of that will show up in fine-tuning too. Fine-tuning is usually where you can start to interact with the model and make it serve your own needs if you're using something that's pre-trained. So, this is where, do you know your domain? Do you know all the players involved? Do you have access to all that data? This is where a lot of the data governance, a lot of your stuff that goes into AI to make it your own, to make it useful for your use case, is going to start to kick in. Same with grounding. So grounding can either be on unstructured, so you're grounding it on, let's say you have a confluence or you have a place where people are adding their knowledge, or you're going to have something like a knowledge graph where you have the things you define in your organization, the data, where it belongs and what you want to do with it, and how it's defined depending on the discipline or the domain or the department or whatever it might be. So all of those things are going to be really prominent in the fine-tuning and grounding space. Those are two separate. I've heard some people describe them as, in the same space. Again, it depends on who you talk to, but I'm going to section them out as two separate things because I do believe that grounding, especially when you have a knowledge graph to ground off of, is something that is a very different approach than just a regular fine-tuning, because the fine-tuning is really looking at the model, whereas grounding is supplementing the model a little bit. So that's why I'm breaking them out as separate things. But both of them are highly dependent on, did you get the right data? How trustworthy do you know your data is? Yeah, it came from your organization, but we all know we have dirty data. We all know we have it, right? So are you going to get the entity resolution correct in there, right? Like that's another aspect to, especially with grounding. You can do that when you're using a knowledge graph. You can entity resolute, right? You can resolve to the right entity so that you're getting the right customer, you're getting the right company or the right system or whatever it might be, because you've taught your knowledge graph or you've already used it in fine-tuning if you're using it to train a small language model or add that as supplemental data later on. Those are things that you really have to understand what you're doing with your data, because that's where, again, if you don't know what's in there, maybe you don't even know the quality, you just don't know what's in there. Okay, well, that's not going to help you because now you don't know if your AI is going to hallucinate because it doesn't have the data to help you. Or I know Juan Cinqueda has a whole article on this exact topic where even if you're just grounding your AI off of a knowledge graph that understands the sequence of things, or I know Amy Hodler talks about causal graphs, what comes after the next logical thing so that the AI doesn't screw that up. If you don't know, how is the AI going to know? And if you don't have it in a codified way that the AI can consult, whether it's in fine-tuning or grounding, that's going to cause you problems later on. The next one is talking about generating a knowledge graph using AI. So this doesn't necessarily show up in AI training all the time, but if you don't have a knowledge graph to do grounding, a lot of people use something like GraphRag, where they are generating a knowledge graph. Here's the kicker with that. It doesn't come with an ontology. I mean, you can use AI to also generate an ontology, but in both of these cases, it's good clay on the table, but you need to go in and make sure that it's actually representing your organization, your use case, your needs appropriately, or it's not going to do what you want it to do. So if you are using the AI to either generate the ontology or generate the knowledge graph, you really want to make sure that you do all the things that we know go into a good knowledge graph. If you're using an ontology, you need to understand, how do you define customer? How does everybody else define customer in all of your data sets? Does all of your schema agree on how these things are defined in the data itself? When you're looking at populating an ontology, let's say you already have an ontology and you want to use GraphRag to then populate it. Are you pointing it at the right data? Is the data going to be translated correctly? So is it going to populate that ontology correctly? Because maybe in your data, you need 2 columns to actually be merged, or you need to translate a date column into a certain format. If you don't know that, if you haven't consulted and done your due diligence in assessing your data before going into the GraphRag or knowledge graph or ontology space, you're going to be hurting later on. And the other thing to keep in mind is it's so easy to use AI to create these things now. It's not a bad thing, but it's almost too easy. Meaning, I've heard from a lot of people that using AI to create their knowledge graph or their ontology, it might be good clay on the table, right? Like we've all stared at a blank screen and said, oh, where do I start? But I've also heard that some have claimed it is just as much time and effort creating it from scratch than going in and fixing and manipulating everything that the AI spits out. So it's very dependent on your use case. It's very dependent on your data and what you're trying to do. But just keep that in mind that sometimes AI now is so easy to just jump to that as your solution that you don't think about how much effort it's going to be to do your due diligence and check it and correct it. Whereas maybe starting from scratch is a better option. Again, it's dependent. Go check it out for yourself, but that's just another cautionary tale. Another area that, again, isn't only in the training space, but feeds into the training is entity recognition. So I've mentioned that a few times in all of these. So this is something that, if you don't know where the data came from, you may not know what entities are in that information. So what that means is if an Ashleigh Faith, me, shows up in your data, do you know it's me, Ashleigh Faith, or the other Ashleigh Faith that exists? I think she works in like hospitality or something. I don't know how there's 2 of us, but there are. So if you don't have an ID to resolve me versus the other Ashleigh Faith, you could be mixing us up. I know the other Ashleigh is on LinkedIn. We're in that graph that has to be entity resolution in there somewhere. Now, I think we do both use different middle names, so there is that. But you're not always going to get that. I once worked on a graph where within a 1-month period, Barack Obama, who was in his 2nd term at that point, so he existed in the data already. First month on the job, he was created as a new entity 50 times, I think. Ugh. And it's because, there was automated things going on. There was no entity resolution happening. And so there was a massive project that had to kick off to do entity resolution on all the data because there was no rhyme or reason. And if you unleash your AI on that, AI is smart. It's going to be able to understand Michael B. Jordan versus Michael Jordan, the basketball player, because there's 2 really well-known entities. But in your data, how many people, how many companies, how many things in your data are that distinct in the rest of the world that the AI is going to be able to figure that out? Or do you need to give it some help, right? So that's where that entity resolution is going to be helpful, and it's going to help you throughout the whole process that we've just talked about. All right, so I did mention that we were going to talk a little bit about then how do you put all this into practice, right? So there's lots of stuff in the news about, this model and that model, it did this kind of training, it that kind of training, it cost this much, it was this high of quality, all of these different things. But the thing that drives me nuts is there's not enough conversation about when you're doing all this AI training, how many iterations, every single layer of this cake that I just described can take you multiple iterations to get right. You have multiple quality assessments. You have to understand the latency and like all the things that go into ML ops. You got to do in every single layer. That costs money and resources. And you have to also imagine that the model that you all are using, whichever one it is, it went through multiple iterations of this. And so every single one of those iterations adds to the cost, adds to the resources used. So just keep that in mind every time you're reading or listening to some of this, because it's like baking a cake without any recipe. You got to try a little bit of this, a little bit of that. You're going to have some failures. You're going to learn from things. That's a lot of machine learning and AI. But unfortunately, when you read about this in the news and you listen to some folks, it might just sound like they had a pre-made recipe in their head, passed down from grandma's past, and it's just perfect and amazing, and look how great it is. But the reality is your grandma had to do those experiments too. So whether you did it or whether the grandma that you got it from, like if it's an open model, somebody had to do it. It didn't just mysteriously happen. So keep that in mind. Like when you are looking into all of this stuff, when it comes to AI training, it's multiple iterations, and each of those will cost you something, whether you're doing it or somebody else did it. All right, so I hope this whole video has been helpful, enlightening, I don't know, at least entertaining. This is something that I've heard so many people ask me, which is why I made the video. All right, so I want to thank you very much. I hope you've enjoyed this video, and I'll catch you next time.